Hey everybody, this is Larry. This is day 21st of the Leetcode Daily Challenge. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about this one. So today we have 78 subsets. Given a unique I did get a question about why about yesterday's problem, about why it was considered easy and not, because this one is medium. I would say the difficulty doesn't matter in a sense that, you need to know this for an interview, to be frank. And of course, if you do competitive, this is very basic stuff. So I think the difficulty doesn't matter as much as just being good at it regardless of the difficulty. That said, things have gotten harder over time, and I do not consider it backtracking. There is a difference between the sort of brute force and backtracking. Power set enumeration and backtracking are two different things, even though one can include the other. For example, you can, there is some, depending on what kind of work you want to be done, there can be subset things in or power set things in backtracking, right? So it is a little bit different, but nonetheless, like I said, I don't know. Look, I am not on a Leetcode difficulty setter thing, right? So I don't know. I would also say that, like I said, it doesn't matter in the sense that you need to know, you need to be good at it, or you should be good at it in either case. So for me, it's less interesting what the difficulty is. The borderline between easy and medium. I mean, there's some medium problems that are very easy, and so some easy problems that are kind of weird if you haven't done them before, especially, right? So yeah, today we have 78 subsets, so I guess we are on that theme of doing power sets. So let's get started. I mean, I think it's gonna be the same thing as we did yesterday, right? So then we just kind of, what do we call? Maybe we could call generate, right? We have an index, and then it's just whether we use index and then the current array. And here it's a little bit, I mean, some of it you have to think about how you want to a little bit trade-off between side effects and state machines and all these things. But if index is equal to n, then we looked at all the indexes. Then now we want to append. Remember, these three characters are important because we want to make a copy of it. Otherwise, you're not going to do it. Otherwise, generate index, index plus 1 current, so that just skips it. And then we also generate this while this does not skip it, right? So we could append, nums of index, of course, and then pop afterwards, right? It's just pop. And yeah, and that's pretty much it, really, right? And then we're going to return answer, and yeah. Like I said, this is pretty standard stuff, pretty straightforward stuff. I'm not, like I said, yeah, I keep on saying that. But it is simple, not that it is easy, right? So there's a differentiation there, there's a distinction there. So, but nonetheless, you have to be good at it. It is a building block for a lot of things, including dynamic programming, for example. And as an example, though not necessarily in the same way, but yeah. So yeah, that's all I have for this one. Let me know what you think. I guess to go over complexity, we do 2 branching for each index. So this is going to be 2 to the n, which is 10, which is fast enough. And right, at least. But actually, at each of these, we actually make a copy of the current array. So it's actually 2 to the n times n, but that's fine. At least for small enough n's. But it gets very not fine very quickly. But yeah. Anyway, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, good mental health. I'm going to do one more problem, so stay tuned. I'll see y'all later and take care. Bye-bye.